Okay, hi everybody. I'm back. Sorry about the break of the video, but working from home has its limits. Finishing up 16.4. So now I have an example of when you have a fraction as a radicand that also has variables with it. So the first thing I want you to do is I want you to write this as two fractions, or as a separate numerator and denominator, sorry. Now, I want you to go ahead and I want you to break the top up. Each one of these terms has its own radical. So in other words, I can break this up as radical 2 times radical x squared times radical y, which is going to be over radical 3. Now, I told you way back in the beginning of the chapter that the radical undoes the square. They're opposite operations. So when you think about that, the radical cancels out the exponent of 2, leaving you just with x. So if I rewrite this, this is just going to be the easiest way for you to think about it. There's more math involved that's behind the scenes that you'll learn in another math class. So if you think about this, the square cancels out the radical, leaving you just with x. And that x is on the outside of the radical because its radical got canceled. So you're going to have x, and then you're going to have radical 2, and you have radical y over radical 3. So as I'm looking at this and I'm trying to decide if this is my final answer, ask yourself, I know this isn't my final answer because I can't have radical 3. I can't have a radical in the denominator as my final answer. Okay, that's first thing. I can't break 2 up. It's not a perfect square. I can't break y up. It's not a perfect square. And I can't break 3 up. It's not a perfect square. So what am I left with now to do? Well, I'm left with multiplying both the top and the bottom by radical 3. Okay, so I'm going to come down here. So on the top, I have x, radical 2, radical y, radical 3, over radical 3, over radical 3 on the bottom. When I multiply it together, my x stays on the outside. I have in my radical 3 times 2, which is 6. And then I just have y, so I rewrite him. So on top, I'm going to have x radical 6y over, this is going to give me what? Radical 9. 9 is a perfect square. The square root of 9 is 3. So then I have to ask myself, again, I keep asking myself over and over again, can I simplify this further? Well, my radical's gone out of the bottom, so I'm good there. Can I reduce? These are my two things that don't have radicals. No, I can't reduce them. I can't break this down. Are there any factors of 6 that I can break down to get a perfect square out? No, there's not. That's how I know that this is my final answer. You got to go slow. There are a lot of steps, but they're the same steps that you do on every single problem. Break it up into 2. Now I'm going to take these and give each factor its own radical. Now I came over here and I said, okay, are there any perfect squares? Yeah, x squared is a perfect square. The square and the radical cancel each other out, which will bring out an x to the outside of the radicals. I rewrote radical 2. I rewrote radical y. I brought over my radical 3. There's nothing else I can do up here, so now I'm ready to simplify by getting rid of the radical that's in the denominator. I multiply both the top and the bottom by the same radical 3. When I multiplied the top and the bottom by radical 3, I brought my x over. That 3 times that 2 is 6. Brought my y over. That's all under one radical now. I wouldn't leave it as radical 6 radical y because that wouldn't be considered simplified. So in other words, I couldn't have this as a final answer. That's wrong. It all has to be written underneath one radical. And then radical 9 on the bottom, square root of 9 is 3. So I have to go through all of those steps. There are going to be some people they'll give me different things. They'll give me that. It won't be correct because nothing's been done. They'll give me this. That's not going to be correct because there's a radical on the bottom of it. So there's a couple different places that you can make a mistake along the way. Okay, so that's when you have variables in there. If you have something squared, if you have y squared, x squared, z squared, if it's under a radical, the square and the radical cancel each other out. You got to remember that. I probably would write a note down about that and highlight it. That's kind of a big deal. Okay. Okay, I'm going to show you one more. This is using a cubed root. So if you remember, we said there were perfect squares, and we said there's perfect cubes. So like 2 times 2 is 4. 4 is a perfect square. Okay? So when we have the square root of 4, remember my index number is 2. So that's the whole circle. 2 or 2 squared is 4. If I take the square root of 4, which is the opposite of squaring, I go back to my 2. Now, when I'm talking about perfect cubes, let me go ahead and write this out. I'm writing these separately. Okay. So, when I'm talking about cubes, this isn't just as easy as saying, okay, I'm going to move the radical by multiplying it by radical 2. Because this index number is a 3 and this index number is a 2. The reason that this works when they're just square roots is because 2 times 2 is 4. Radical 4 is 2. 4 is a perfect square. That's why I can just take when it's a square root and multiply it by itself. But in this problem, it's not a square root. It's a cubed root. So instead of just multiplying this by radical 2, I'm going to have to multiply this by 2 times 2. Follow my reasoning here. Cubed means 3. I now have 1, 2, 3 2's. I now have 3 2's. 2 times 2 is 4. 4 times 2 is 8. Is 8 a perfect cube? Yeah. 8's a perfect cube of 2. So I have to multiply both the top and the bottom, not by 1 radical 2, but by 2 times 2. Because remember, I do to the top what I do to the bottom. The bottom is what decides what I'm going to do. I need to move this. My index number is 3. That means I have to have a total of 3 2's on the bottom. My original problem, I have 1 2. This index number is 3, so I'm going to have to multiply 2 more 2's. If this index number was 5, if this were 5 and this were 2, I'd have to multiply by 4 more 2's. If this were 10, and I only had 1 here, I'd have to multiply by 9 more. So whatever my index number is I have to have a total of that many factors that I'm multiplying by. So, and I'm trying to show you why. They all have to have the same index number. So when I multiply 2 to the, blah, 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 I can't talk. It's late, believe it or not. This is a cubed root of 2 times the cubed root of 2 times 2 is 4. So we multiply them all together. When we multiply all the bottoms together, we've got 2 times 2 times 2. On the top, we've got our radical. And what do we have up here? We have 3 times 2 times 2. 3 times 2 times 2. So let's go ahead and multiply. 3 times 2 is 6, times 2 is 12, over 2 times 2 is 4, 4 times 2 is 8. Make these a little big. So, we're looking at cubes, because these are 3's. Is 8 a perfect cube? Yeah, of what? We just talked about it. It's a perfect cube of 2. Is 12 a perfect cube? No. Is there a perfect cube in 12? So can we break 12 up into factors, one of which is a perfect cube? No, because 2 times 2 times 2 is 8. 8 is our first perfect cube, right? 3 times 3 times 3 is 27. That's our second perfect cube. 8 or 27 are not in this. So we can't do anything else to break that down. It's not like we can look at it and go, break it down into 4 and 3. 4 is a perfect square, but we're talking about cubes. So is that going to be my final answer? That's my final answer. I can't do anything else to break that down. I no longer have a radical down here. I have one more example on that paper I'll talk you through real quick. This is going to take a little bit of thinking, but you know what? Once you think about it, it's like the light bulb's going to come on and you're going to be like, oh, this makes sense. And she's not going to give me anything higher than a cubed root on the test. So you got one more example on there. We have the cubed root of 3 over the cubed root of 4. Okay. Neither this 4 nor this 3 are perfect cubes. Okay. We have to simplify, right? We can't break these down. We have to simplify by moving this radical up. We're using an index number 3. We only have 1 4 here. So we're going to have to multiply it by how many more 4s? 1, 2, 3. So we're going to have to multiply the top and the bottom by 2 4s. I'm sorry. Math makes me happy. Okay, why do we do that? We do this so we have a perfect cube on the bottom, so when it simplifies, the radical is going to go away. All right, so what we have on the top is we have the cubed root of 3 times 4 times 4 over the cubed root of 4 times 4 times 4. So, like I said, it's late and I'm tired. So we got 4 times 4 is 16, times 4 is 64. So let's come down here. So we've got the cubed root of 64 over 3 times 4 is 12, times 4 is 48. Is 64 a perfect cube? Yeah, and if you don't remember that, use your calculator. 1, 2, 3. It's the perfect cube of 4. And you can put it in your calculator if you don't believe me. I showed you how to do that before. So this breaks down into 4. Now up here, we have to prime factor 48 to see if there's a perfect cube in there. But to try to save time, when we talk about our perfect cubes, remember, 2 cubed is what? 8. 3 cubed is 27. 4 cubed is 64. So 48, none of these factors are in 48. So there's nothing we can do to break that down further. So can I do anything else? Can I reduce anything? No. That's as good as I get. Or is it? Nope. Come to think of that, I made a mistake. Come to think of it, I made a mistake. Because I can take an 8 out of there, can't I? See, if you were here, you'd be raising your hand in class going, Miss J, isn't 8 a factor of 48? Yes, it is. This is what happens when I've got a peanut gallery upstairs. So I can take out 8. 8 times what is 48? 8 times 6 over 4. Almost missed that. I apologize. Okay, so let's... my markers are dying too. Okay, so let's finish this up. So 8 cubed, when we take the cube root of that, it's going to be what? 2. And then we got our radical 3, 6, because we can't do anything to clean that up, over 4. See, just like that, it's that easy to make a mistake. Now, can I do anything else? Yeah, because look, I have this 2 that's on the outside of the radical, and I have 4 on the bottom. They have a common factor, right? 2 goes into 2 once, 2 goes into 4 twice. So what am I left with on the top? I'm left with 3 radical 6 over 2. So is there anything else I can do to that? No, because I can't do any reducing between that 2 and that 6. There's no perfect cube in 6. I can't break 6 up into a perfect cube, which is what I did up here. So that is my final answer. And this is why you won't wait till 11 o'clock at night to do the test when I post it, because you make stupid mistakes. Okay. We got one more on the back. It's got variables in it. Okay, so we've got the cubed root of 4 over cubed root of 25y. Okay, so I look at this. Is 4 or 25 a perfect cube? No. All right. So what can I do? Well, I can look at it like this. I can write this like this as well. What are my factors of 4? 2 times 2 is 4. So these are exactly the same things. Do the same thing down here. 5 times 5 times y. How come I did that? Because if I'm looking for a perfect cube for down here, look, I have 2 5s. I need to multiply this by what? Another 5, because I need 3 5s. So this, when this simplifies, it's going to, excuse me, it's going to simplify into a perfect cube. Also the y, though. I can't just have radical y left in the bottom. So I have to have 3 5s, so it'll simplify. And I also have to have 3 y's, so it'll simplify. Now I have 3 5s, I have 3 y's. So you can see where this is going. Now what I do to the bottom, I have to do to the top. So I also have to multiply the top by a 5y. Because my index number is 3, so I need 3 of each factor. So up on top, I'm going to have radical 2 times 5 times y over, guess I'm going to have to get some more markers, 5, y. Okay, so you don't even have to worry about 5 times 5 is 25, times 5 is 125. You can just go, oh, look, I have 3. 1, 2, 3. So I know that that's going to simplify into 5. Or if you want to write the whole thing out, go ahead. 125 over y cubed. And then put it in your calculator. It really doesn't matter to me which way you do it. Whichever way is easiest for you. But 125 is a perfect cube of 5. Y cubed is a perfect cube of just y. If you're seeing the shortcut, then go ahead and do it. If you're not seeing the shortcut, then write it all out. Then on the top, we've got radical, there's our 3. We got 2 times 2 is 4. 4 times 5 is 20. Y times y is y squared. So now you got to ask yourself, can I do anything else to that? Can I reduce anywhere, my y's, my 20, my 5, anything? No. My denominator is all good. I don't have a radical down there. I can't break 20 up into anything that's a perfect cube, right? My factors of 20 is 4 and 5, so I know I can't reduce that down any further. So that's my final answer. So there's an example when you have variables. You have to take into account the variables too. When you're talking about a perfect cube, you know, I'm talking about a perfect cube. I only have 2 5s, so I got to multiply by 1 more. And I only have 1 y, so I have to multiply by 2 more. There's a video, if you, what did I do? If you put in rationalizing the denominator with cubes, I found some pretty good videos on there that'll help you. The guy goes through, he goes really slow, and he tells you the same thing I'm telling you, but it might help you to hear it from a different person. So go ahead, just go to your Google and just type that in that little fat bar right in the middle where you search stuff, And the first one that comes up is pretty good if it's the first one that came up for me. So he tells you the same exact thing, nothing crazy, nothing wrong. Okay, so that's the end of 16.4.